All right, so B and C are going to be based on the equation that we had. Okay? And so we have what is the lowest maximum height needed for a field goal to be made. Okay, well, we need to go back to Desmos for that. And this is the lowest height we possibly have. Okay, or lowest height that the ball needs to travel. It could go higher than that, but it can't go lower than that based on the data that we have. Now, 17.841 is the length that it has to travel to get there. Y is our height, and I need to put those in there. Okay, X is the distance in yards, and Y is our height, not height, and that is in feet. Okay, we always need to make sure we have this on there so that we understand what we are using. Okay, our height right here, 18.67 feet. Now the ball will have to travel at least this. Now technically, if it goes under this, it'll get blocked. So we would actually round up to 0.68, not 0.67. We went round on 0.67. So we would say, here we go. Okay, that for B, the ball must reach a minimum height of 18.68 feet in order to make the field goal. And that's one of those points we have there. That's our little max point that's going to be on top right there. Okay, so that's how we come up with that one there. Now, how far will the ball travel before it hits the ground based on nothing stopping it? All right, so that would be right here. This is where it hits the ground again. That has a height of 0 based on everything being completely flat. That's what we're going to call it. And that would be at 35.68 yards it will have traveled as it creates this field goal. Now, if you want to draw a little field goal right here on your graph, you gladly can do that. You do not have to. That is not at all a requirement, but you definitely can do that. And so our next answer there, 35.68. The ball will have traveled only one L in traveled E. 38, 35, 8 yards before it hits the ground. Okay, now these are points that we need to make sure that we have in there and that we're going to make sure that we put into our graph. I'm just going to make this a little bit smaller. And then actually, let's make it really big. And we'll get rid of that because we don't need that anymore. Okay, I'm just making it a little bit bigger so that I can put the graph underneath. Okay, just trying to organize these notes a little bit as you're watching. Woohoo! That's what a good teacher always does, I think, right? All right, so now we have this here. We need to make sure we show our graph that has everything on there. Let's put our 17.841 x equals 17.841. There is our axis of symmetry. And I'm gonna, there we go, make it a dashed line, very important. Okay, we have all of our important points that we were given. We have that one right, or that we kind of came up with, and we have this point right here. These are all the points that we have used in solving our problem, and we want to make sure we show all of this, and there's all this is going to be our equation, and so on and so forth. And then we're actually going to add a little bit more here yet, but let me just snip this graph. Again, previous graph. And so this is the graph that I'm going to snip. I'm going to make sure I have my what X and Y are. And I'm going to plug this into my document. Make it small enough so that it fits. There we go. Okay, so there it is. Now, can you think of anything that might be missing? You bet. We need our domain and range. Okay, so our domain is going to be from 0 to 35.68, and our range is going to be from 0 up to there. I don't have enough time to put in that in the video. It will be in the notes, but make sure that you have domain and range in your graph as well.